everyone, today I'm going to talk about covalent bonding, Vesper, and hybridization. Okay, so first, what is bonding pair and what's lone pair? So bonding pair is an pair of electrons that is shared with other atoms. And lone pair is an electron which is not shared with other atoms. So what is resonance? So sometimes you can see, for example, ozone. So when you draw things, you can draw like this. But actually, it's not fair because the first oxygen has only 2 bonds, and the second have 1 bond. So they will just switch. So you need to use 2 or more Lewis structure to represent it, or you can draw it like this. Okay. So actually, what is resonance? Resonance is just some bonding that you need to use 2 or more Lewis structure because they will switch different bonds. Okay. So exception of octet rule. We know most of things have use octet rule to covalent with other things, but sometimes that the whole, like the NO2, the whole electron number is odd number. So you can't form any octet rule. For example, the valence electrons of oxygen, how much? 6. Plus nitrogen is 5. So 6 times 2 is 12 plus 5 is 17. So it's odd number. So it's impossible to form octet rule. Another things. Okay, maybe it is fewer, so the total, so that means something that is fewer than only 8 electrons. For example, this. Okay, so let me see the periodic table. Okay, so how much is B? 4 is in a second group. Okay, second group. Okay, so it's in a second group, so we have 2 valence electron and plus hydrogen, and so he had only 4 electrons, valence electrons. So it's not 8. So it's exceptions. Another PCl5. Okay. So you can see Cl is 7. They need only 1. So how much is P? P is 5. Okay. So one thing, if it's ionic bond, it's right, but actually it's covalent bond. So there's something strange now you can see. So they share, so P is 5 plus 5 is equal to 10 is more than the octet rule. So those are some exceptions. Okay, so now what is Vesper? Vesper is the whole name. The whole name of Vesper is valence shell electron pair repulsion theory. Okay, so they didn't count the theory. Okay. So, no structure can't predict all geometric shape of molecules. So, Vesper can predict it. For example, and like A stands for the central atom, B stands for the surrounding atom. So, AB2 like the BeS2 or CO2. You can see if this is CO2, you can see it's 180 degrees, just flat. Because 116 degrees divided by 2 is 180 degrees. Okay. And another, AB3 like a BF3, you can see this picture is 120 degrees because 360 degrees divided by 3 is equal to 120 degrees. Okay. And another little stranger, it is more strange. So why? So like a CH4. So how much CH4? So CH4, you draw it like this. So you draw it like 90 degrees. Actually, it is 109.5 degrees. Like this, it's a little just like a cube. So it's 3 dimensions. So, but you can only draw flat. Okay. So another AB3, like a NH3. So you will think NH3 should be 120 degrees. But actually, lone pair need to consider one room, so you will think, oh, 109.5 degrees, but the strong is 107 degrees because that electron pair will make more pressure down it, so the degree will become more smaller. So there's lone pairs right there. Okay, yes, Sam. Okay, so another. So you won't think, hey, I know one thing, that if there's 4 hydrogen, it's sp3, right? But that's wrong. So because that sometimes there's lone pairs, right? I tell that before, there's lone pairs. So lone pair consider one room. And you want to see this. Wow! This should be 180 degrees. That's like CO2. There's only 104.45 degrees. So why? Because there's 2 lone pairs. So it should become 120 degrees. But it just compressed, and now it's only 100. So it should be 107 degrees, right? That's the NH3. And then it just compressed, becomes only 104.45 degrees. So or you can just say 104, or you can say 105 degrees. It's similar, okay? Another, sometimes strange, like this. Did you think something looks like molecule looks like this? So you will think it's strange that why it looks like this. So this is 180 degrees on the top, and then it's other degrees because there's some lone pairs too. So you can see there's 1 lone pairs. So you can see like this. So you can fall like this. 3 right here, and 2 on the top and the bottom. Because the first there's only 4. It's 4, so you're going to think it should look like CH4 or other things. But why it looks like this? Because there's lone pairs. So you still think there's 1, 2, 3, 4, 5 fluorine. So 1 on the top and 3 on the side. So it looks like this. But you didn't draw the lone pairs when you draw molecules, so you will think why it looks like this? Because there's something on the top. Okay. So valence band theory. So first we know that covalent is a band length. So from this nucleus to another nucleus is a band length. Okay. So and when some covalent bond form, they release some bond energy. This energy is called bond energy. So covalent bond forms some energy when it's formed. Okay. So first, let's see some things. Hydrogen gas is H2, and hydrogen is 1s1. So when you draw it, you can draw like this, and when you draw in Lewis structure, you can draw just like this. It's very simple. Just become gas, and the Cl2 is similar, maybe same, okay, but the HCl is a little strange. So like this. So the blue orbital is the HCl, and the round one is the H hydrogen. Okay, so when they form, so you can see it looks like this. But there's only a sigma bond. When you draw it, you can only draw one line between the hydrogen and the chlorine. Okay. So, but now, what about pi band? For example, nitrogen like N2, you will think is similar to hydrogen gas or chlorine gas, but nitrogen gas is a little different. So you can draw it like this. Wait a second. Okay, so there's 3 bond, and there's 3 bond between them. So the first one is called the pi bond, and the second and the third is called the first one is a sigma bond, and the second and the third is the pi bond. Okay. So it will like this. So because you can't just draw like a flat line, of course, so you have to draw something because you need to use 3. So you can draw like 2 sticks and 3 like this. Like just like this picture. And this is the pi bond and the pi bond and this sigma bond. Okay? What is hybridization? Hybridization is a mixing of the orbitals of and mixing of orbitals, and the one electron of s maybe can promote to the p orbitals. So it can form sp1, sp2, or sp3 or other numbers. Okay. So hybrid orbital first one is sp3. So most common, you can think of the CH4 or some water there. Let's see about CH4. So there's 4 hydrogen. So you make 4 rooms with only 1 electrons, unpaired rooms. Okay. So now you can. So first, what is carbon? Is 1s2, 2s2, 2p2. Okay. So now, how does it do? So you need 4. So first, they promote the 2s1. So you can draw it. Wait a second. Okay. So draw this. Like you promote this. Oh, it's too thick. Wait this. Okay. So this is promoted to here. So it becomes this. And hydrogen, 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 and hydrogen. Just like this. Okay. Okay, so yes. Okay. So it looks like this, we already know. So it's called sp3. So I think I talked that before that. Oh, so 4 hydrogen means it's sp3. Then 3 hydrogen like NH3, you think that's sp2. You can think it's very happy, but it's not right because lone pairs. So because there's some lone pairs, so it's not always that form. Okay. So the NH3 now you're gonna think, oh, it's just sp2. Now you will find sp3. So you will think why it is sp3. Okay. So what's sp3? Because there's 1 lone pairs. So because there's 1 lone pair, you can consider it's like NH4, or you can consider S4 as the same things. Because I said that lone pair you consider 1 rooms. So that's why. Delete it. Delete it. Okay. Hybrid orbitals sp3. Okay, so remember this. Wait a second. Okay. So now you can know that the H2O is the sp3 we know because there's 2 lone pairs. So 2 plus 2 hydrogen is equal to 4, so it's still sp3. Okay. So sp2. So sp2, here's some sp2. For example, like a BF3 is an sp2. That B is this, and F we know. Okay. So you can do it. So first, this like this, and you promote this to here. So there's 1 empty space. So you don't consider this. So there's only 2p. So you call this sp2. So ozone is just free oxygen. So first let me see. So because first we see, because we know that it's resonance, so it's just switching. Because switching, so we don't count it. Okay? So they don't count it, so it lost 1 room. So 1 orbital, so it's only sp2. Because there's 1 room is missing, so there's only 2p. So it's called sp2. So that's why it's ozone is not sp3. So you will think ozone is sp3, so actually it's sp2. So first, now sp, so BH2. Okay, so BH2, so BH2, so it's the sp(y), so it's very simple. So you can just see BH2. So P is 1s2, 2s2, so there's no P, and they promote 1, 2s2 to the P. and become like this. And so there's 2 unpaired. So each hydrogen just goes inside it. And then it's done. So there's only 2. So there's only 1p and 1s. So it's called sp. Thank you. Bye bye.